Good afternoon, everyone. Today we're going to simplify these two products and quotients of rational expressions, and we're going to state all non-permissible values. So first of all, let's factor every one of these expressions as much as we can, and then it'll be a lot easier to see our non-permissible values. So for A, our first numerator, 4z squared minus 25, that is a difference of squares. And so factors as 2z minus 5 times 2z plus 5. And that's over our first denominator is going to need to be factored by decomposition. So what two factors multiply to make positive 40 and add to make negative 13. That'll be negative 8 and negative 5. And then we have to do decomposition. I'll give you guys time to do that if you'd like. But if you do factor it, you'll have 2z, whoopsies, 2z, you'll have 2z, and then you'll have minus 5, and you'll have z minus 4, I think, yes, z minus 4, like so. And now we're multiplying these two expressions. When we multiply, we can put everything over just one denominator as one entire fraction, since these are all multiplied together. And so we have a factor of z minus 4 in the numerator, and we can factor it a 2 from 4z plus 10. And inside brackets, we'd have 2z plus 5. And so now this is super convenient to read off all of our non-permissible values. Again, the non-permissible values are simply the values of z that would make our denominator have a value of 0, in which case our expression would be something divided by 0, which we can't have. And so all values of z that would render this denominator 0 is if z was positive 5 over 2, right? If any of the individual factors were made to be equal to 0. So for 2z minus 5, this would be made to be equal to 0 if z was positive 5 over 2. So z cannot be positive 5 over 2. It cannot be negative 5 over 2 either. So we can say can't be positive or negative 5 over 2. And from the z minus 4 factor, z cannot have a value of positive 4. And now to simplify this completely, we can just cancel out all common factors to the numerator and the denominator. And so 2z minus 5 cancels out, 2z plus 5 cancels out, and z minus 4 also cancels out. And so all we have left, if we can really see, is 2. We know that if all factors in the numerator cancel out, there's still a 1 there. And so this cancels out and reduces, let's say simplifies down rather, to a nice value of 1/2. And that's it. Okay. For part B, we're dividing a rational expression by rational expression. We divide by flipping this one, taking the reciprocal of the second rational expression and changing the division to multiplication. And so that means that we're going to have v minus 5 over v times v cubed over v squared minus 2v minus 15. Let's factor that to save ourselves a line of work. This will factor as v minus 5, v plus 3, right? And now we know that this is being multiplied, and so we can group everything over one common fraction, one common rational expression. And so we have v times v minus 5 times v plus 3. And we can finish that off. So at this step, we can cancel some stuff out. The v minus 5 factor can cancel out. V cubed divided by v. V is the same as v to the 1. So our exponent rules say that when we divide by the same base, we subtract exponents, right? And so one factor of v cancels out. So this one is completely gone, and v cubed is now v squared, right? One factor of v canceled out in both parts. And so we have v squared all over v plus 3. And that is our simplified version. We also did not state our NPVs. Let's do that. Non-permissible values, again, let's look at them in this stage here. We can't have VB 0, we can't have VB equal to 5, and we can't have VB equal to -3, because again, any of those values would make one of these factors 0, and since these are all multiplied through, any one factor being 0 means the entire product is 0, and the denominator of 0 is a no-go. So our non-permissible values are that V cannot hold a value of 0, 5, or -3. And we are done. So factor in whatever order you think is most convenient. I like to factor first, that way it's easy to read off our non-permissible values, and then we can cancel out common factors early on. And this is how I recommend you go about it as well. So I hope this helps, and thanks for watching.